All right, this is lesson 5.4, factoring and solving polynomials. Now, I will say that we're actually going to move into factoring polynomials. There's a couple where there's some special factoring patterns that we're going to need to look for. And so I would highly advise you to make sure you have a piece of notebook paper and you actually take some notes on this. Write down the examples. If you need to, you can go ahead and take some notes, pause the video, and would be a great place to make sure, like I said, take some notes and write some of these problems down. All right, so let's go ahead and get started in this. And the first thing we want to take a look at and explore is some of our special factoring patterns. So there are two of them. The first one is called the sum of two cubes. And what we mean by the sum of two cubes, the first term and the last term in these have to be perfect cubes. And your answer when you're is going to end up, you're going to take the cube root of a to the third, which would be a. The first sign is a plus inside of here, and it's the cube root of b. So it'd just be a plus b. The trinomial is going to be a squared minus ab plus b squared. Okay? All right, so let's actually take a look at one of those when we're doing those. So if I wanted to let's do x to the third plus 8. Okay? So remember, my first term is my a term, and it is a perfect cube. And 8 is a perfect cube. Okay? So we're basically looking for what numbers can I multiply times itself and give me 8. And you're going to find out that your a in this case ends up being x, and your b in this case ends up being 2. Okay? And if you actually find the cube root of those, it's going to make solving these a lot easier. Okay? So all it's going to be is x plus 2 is the first term. Okay? Times square the first one, which is x squared, minus, multiply them together, so we get 2 times x, 2x, and 2 squared, which is 4. Okay? And that's all there is to this one. Okay? The only difference in difference of squares is you're going to do the same thing, take the cube root of each of them, but the first one is going to be a minus b. So basically this sign and this sign are going to flip-flop, because then it becomes a squared plus ab plus b squared. Okay? All right, so let's go ahead and take a look. This one's a little tougher. We're actually going to factor 8x to the third minus 1. Okay? Now, so I'm looking for my a term, so the cube root of 8 would be, again, 2 times 2 times 2, so the cube root is 2, and x to the third would be x. Okay? B, I'm just looking for the cube root of 1, which is going to be 1. Okay? So when I plug this in, it's just going to be a minus b, so in this case it's just going to be 2x minus 1. To get this term, I was going to square, so 2 times 2 is 4, x times x is x squared, plus, multiply them together, and I end up with 2x, and then it's plus, I square the last one, okay? And that is my answer. So that's all there is to it. All right. So let's go ahead and take a look at a couple more examples. So if I gave you x to the third plus 27, okay? So this would be, this one's a perfect square, this one's a, I'm sorry, not a perfect square, it's a perfect cube, and this one's a perfect cube. So my a term would be x. My b term, when I'm asking what multiplies together to give me 27. So 3 times 3 times 3 would be that number. Okay? So, and remember, since there's a plus, I'm just going to take x plus 3. And then the formula is, remember, I'm going to square the first term, minus, multiply them together, and then 3 times 3, which is 9. Okay? And that's all there is to it. That's your answer. Okay? Now, when you look at example B, one thing that we really quickly find out is we don't have a perfect cube. The perfect cube is, for 2 would be 8 again. Perfect cube for 3 is, or I'm sorry, the next perfect cube is 27. And so the first thing I'm going to have to look at is can I factor out a monomial? And the first thing is I know I can take this one and divide it by 8. Because, well, first of all, let's see if we can take 250 divided by 16. And you find out that it doesn't go evenly. So let's take a look and see. Well, the next biggest number I can take 16 divided by is 8. So 250 divided by 8 doesn't go perfect even. Next. So the next number that I can do would be a 4. So if I can divide out a 4, so 250 divided by 4, that one doesn't work either. So then the next one would be only divided by 2. So 250 divided by 2, yeah, that gives me 125. So I'm going to pull out the 2. Also need to pull out the biggest amount of u's that I can do would be a u squared. So 16 divided by 2 gives me 8. U to the 5th, I take out 2 of those, I'm left with u to the 3rd, minus 250 divided by 2 is 125, and u squared divided by u squared cancel out. And then if you'll notice inside that I end up with a perfect cube. The perfect cube of 8 is 2 again. So let's go ahead and write out our A and B, what our cube roots are. I get 2, because the cube root of 8 is 2. And u, and b, the cube root of 125 is actually going to be 5. So this 2u squared, we don't have to do anything with it, with the exception of it has to stay out in front. So remember, I got a minus. I'm just going to rewrite this as a minus b, so 2u minus 5. And then parentheses, I square the first one. 2 times 2 is 4. U squared, change the sign so it's a plus. Multiply them together. 2 times 5 is 10u. Okay, so then just to get my last term, I'm going to do 5 times 5, which is 25. Okay, and there is my answer. Okay, all right. So let's go ahead and take a look at another strategy that you'll do, and you're really going to have to look at these to see, okay, which one's going to be the best method for me in order to do this. Okay, so one other example just to take a look at would be factoring by grouping. Now this typically works when you have 4 terms. So here's my first term, here's a term, here's a term, and here's a term. Okay, and all I'm going to do when it's factoring by grouping is group 2 of them together. Now make sure this negative hangs out with the 9. Okay. All right. So all you're doing by factoring by grouping now is saying, okay, what can I pull out of here? And the biggest thing I have is an x squared. So x squared. So I'm left with x minus, and then x squared over x squared gives me just a 2. Plus, the only thing I can divide 9 and 18 by would be a 2. So I end up with a negative x plus 18 divided by 2. Oops. Let's back up a second. The biggest number I can divide 9 and 18 by would be a 9. And then, so 9 divided by 9 gives me a negative x. 18 divided by 9 gives me a 2. And if you'll notice, inside the parentheses, I'm actually ended up with almost the same thing. I have an x and a 2. The only thing, my signs are wrong. So in order to correct that, we're going to make this a positive 9, right? Or, I'm sorry, this positive 9. We're going to make this a negative 9. And by making that a negative 9, then we can actually change this sign, and we can change this sign. Okay? So now I have an x minus 2, x squared minus 9. Okay? Now, one last thing that you should always do in factoring is make sure that you've factored everything as far as you can factor it. And what I mean by that is x minus 2 can't be factored anymore, so it's just x minus 2. This one is a perfect square trinomial. This is a perfect square, that's a perfect square. So I get x plus 3, and remember it ends up x minus 3. Okay? And so there's your final answer on factoring. Okay? All right. Example number 3 is when you're factoring a polynomial in quadratic form. Now, what we mean by this is a lot of times, if you'll notice, we have a minus sign. So a lot of those rules will apply. So you're basically saying, oh, wait a minute, this is a perfect square. 81 is a perfect square, x to the fourth is a perfect square, and so is 16. So the square root of 81 is 9. Square root of x to the fourth is x squared, minus square root of 16 is 4. And remember, on a difference of squares, I need the exact same thing, except with a plus sign. Okay? And when you're looking at this again, you're thinking, I can't do anything else with this because I have a plus sign, even though that one's a perfect square and that one's a perfect square. But the formula is a difference of squares, so I have to have a minus sign. So you look at the other one, and you think, wait a minute, I have a minus sign over here. This is a 9x squared, so that's a perfect square, and that's a perfect square. So you actually need to make sure and take this one step farther. So the square root of 9x squared is 3x, square root of 4 is 2, and then I just need to make sure and put a plus sign in there, okay? Don't forget to make sure and copy the one that you couldn't break down, okay? Because it has to still be included in that problem, okay? All right, and the last example that we're going to look at under just factoring is x to the third, factoring polynomials in quadratic form. So the first thing that we need to do is, when you're looking at these, and this is a good example of, well, I can't do really factor by grouping because I only have 3 terms. So then you got to look at, okay, can I pull out a monomial? And you could say, wait a minute, they all have a 4 in common, so I'm going to factor out a 4. And then you also need to look at the variables. I have an x to the 6th, an x to the 4th, and an x squared. So you say, wait a minute, I can pull out an x to the squared. So 4 divided by 4 goes away. X to the 6th divided by x squared gives me x to the 4th, minus 20 divided by 4 is 5. X to the 4th divided by x squared is x squared, and then plus 6, and the x squared goes away. And then when we're looking at this, remember the 4x squared will always stay in front, but just because it's x to the 4th, you're actually going to factor this just like we did before. You're going to look for what multiplies to give you 6. So 1 times 6, 3 times 2. Oh, wait a minute, there's my 5, but I need it to be a negative. Okay? So 4x squared needs to stay out in front. Square root of x to the 4th is x squared. 1 needs to be a minus 3, and 1 needs to be a minus 2. Okay? And you look at it and you say, okay, wait a minute. X squared, that's a perfect square, but 3 is not a perfect square. X squared is a perfect square, but 2 is not a perfect square. So this is actually ends up as my final answer when I'm completed. Okay? All right. So this concludes video 2. When you start looking at video 3, the only difference is going to be now we're going to actually be factoring these, and we're going to turn around and we're going to solve them. So and make sure on video 3 that you do the same strategy where you are making sure you're taking notes, pausing the video as you need. Okay? Good luck.